Hello, my name is Jinxi, and I'm a graduate student. Today I will be showing you my assignment 2. So first, let me show my code works, and the main class is called dots and boxes. So I'm going to run the program, and it will show up the path to take a player to win a game. So yeah, here it is. So basically all those printed game boards are the path to take Max to win a game. So there are a couple of important classes here. So the first one is called dots and boxes board implementation. So here I have a successor function called move, and this is this method gives all the possible moves for a player to take in a given game board. So this is a private method, and the public method is called search. So from outside we can call the search function, and in turn call the successor function to get the possible moves. So next class is called search board move. Called have a dots and boxes board implementation. Basically, this board implementation gives us dots and boxes board, which is accessible to both players, Max and me. So there are basic functions called draw. You can give it to configuration, and the classes will give you a board object. And in this board object, you can print a state, or just deep copy board state and pass to player. In next class, we have node implementation. In node implementation, we have a game board. So each node knows the current state of game board, and which player owns a node, and the parents, and the score, and their children. And also a node knows how deep it is. So from get depth method, the node knows at which level it is, and also it implements a compare method to order the score in a priority queue, or a node collection. So here we have a player class. So player in a player class, it can give you a player object, either me or Max, based on your configuration. So the next class is dots and boxes. So in this class we have min-max algorithm implementation. So from start, in the public constructor, we setting up a new game board, and we initiate a root node and put it on the queue, and from here we apply the search algorithm, apply search, and basically the search function just goes into the search board move class and get all the possible moves. So in the min-max function here is the implementation of min-max algorithm. So the first line here, the path is the path that can take a player to win a game, and the second line it's returned array deck from search bar move class, which contains all the possible moves for each player. And in a while loop, what I did was go through all the possible moves to search scores for each player. So here, if it is a mean player, so we get the least possible score. So because the means objective is to minimize the score that Max can get. Also, in other words, to win the game. So if the player is max, so it is trying to maximum its score. So we take the very last node of the path, so it can give the maximum score for max player. This simple implementation, it does give max to 1 every game, but it's not allowing 2 players to place a move randomly on the board, because I just did the whole move iteratively and in a very simple way. I think the mistakes that I made is to trying to search for all the possible moves. So from here, so this is just me trying to having all the possible moves and as a tree. And from the very least level of the tree, so from here I remove from last of the tree structure, and work from that level then up to find values for a max and min. However, it's not really it's a very large state space, so I didn't modeling the problem correctly to have a confined space to search to have a good search space. So I think I'm gonna work on that to improve the implementation. Okay, thank you very much.